Now, we're going to look at an alternate way of doing threading using system.threading.tasks, this library out here. Okay. So first thing is, let's try and understand what is a task. A task is, you can think of this as a wrapper class for a thread. Okay. When you use a task, when you create a task out here, internally, this is using a thread from the thread pool. So we saw yesterday that a thread pool is more efficient than creating your own threads. If you had used something from the thread pool, because it's readily available, the overhead of creating your own new thread is not there. So tasks works on this concept, and it creates a wrapper class for a thread that is available from the thread pool. Okay. Just like you started off a new thread, you would create an object of the thread class and say thread.start. Similarly, you can do a task.start. And that's what you would be doing out here. It gives you, since it's a wrapper class on the existing thread pool class, it gives you a little more features or options which are not available with threads. So things that you can do with threads are available with tasks, plus a few additional things. And the fact that it is also more efficient or would run faster. It's lightweight, more efficient, all of these features. So it is an improvement on working with threads. Tasks was introduced in .NET 4, right? .NET 4 onwards, they introduced tasks. So you might find previous code before .NET 4, which is using threads. But code that you write from .NET 4 onwards, it is recommended that you work with tasks itself rather than working with threads. Okay. So we had to cover threads because you needed to understand what threads were. But going ahead, in most of the code that we'll be writing, we'll be working with tasks out here. Okay. And let's see what we're going to do. Basic same things that we've been doing. Calling a method with a thread can be now replaced by calling a method with a task. Let me go in for a new project out here. What day are we on? Day 10?
10.
All right, so my code is going to be pretty much similar to what we have been doing with the thread, but do it with a task instead. Okay. Everything that you are working with is available in the namespace system.threading.task. Make sure you have, by default, you will have a using, but make sure that this is available before you begin. If you create a task object, task, whatever, let's say T1 is equal to new task. I already have a T1. So let's say T1A is equal to new task. See what it takes as a parameter. What does it take as a parameter?
Action.
So what is the signature of action?
Delegate.
Yeah, it's a delegate, but what is the signature of action?
Action means no, like void and no parameter. Void return type.
Function, it is basically pointing to a function that has a return type of void and no parameters. So this is the simplest way in which you could create a task. There are other overloads to this. Okay, but this is the simplest one that we are using out here. So what I can do here is, I've just, in my existing code, I've got various options. Look at the first option here. What am I doing here in this case? What am I doing here in this case?
So creating
object of type action, making it point to func1 and passing that obj action to task out here. So this is one possibility that we have out here. The second possibility, of course, is what we have been doing all along, that directly given what? The name of the function. You don't need to say new action or whatever, you can directly give in this. So use whatever syntax. I mean, this would be obviously the easiest syntax to use. Are we clear on this, everybody? So I'll just comment out this code and keep it as T1 itself. All right. So these are just alternate syntaxes that are available out here that I'm showing you. You might find people using code like this. You might find people using code like this or code like this, all of which means exactly the same thing. The task is not actually started here. Where does it actually get started? When do we actually start the task? Is on t1.task start or t2.start. And that's what I'm doing with readline. Are we clear on this, everybody? So this is the same function that I had yesterday, wherein I'm just showing you function 1, function 2, running it in the loop. Okay. In addition to that, I've also in my code, shown you the manage thread ID. So what is this manage thread ID? This is actually the ID assigned by the CLR. See, anything that's managed is code that is managed by the CLR. You'll hear this term managed out here. So whatever the ID associated with the, assigned by the CLR, that's the one that is showing to you out here. Okay. What I want to show you here is actually when you're using a task, you're actually using threads itself. So task is a wrapper class for a thread. That's all I wanted to show you, that you're actually getting the ID from where? From the thread class. Let's try running this. So all it did was call the two tasks one after the other. First function called from 3. What is 3 out here? That's the manage thread ID. And the second function called from 4, whatever. So you just got similar code to what you got yesterday, and some code from the first method and some code from the second method is running. Are we clear on this? So this is the simplest way in which you would work with this. Now, to call a method, you have an alternate syntax also available to you. So look at this now. First thing is into methods that I have here, func1 and func2, and see what I'm doing out here. I'm specifying task.run. So there's a method, static method available with the class task class called run, and I'm directly giving function 1. Okay. Can you tell me what is the difference between task.run that I'm doing out here on line number 58 and what I did in the previous example, where I created a task of my own in this one? What is the most striking difference that you would see out here? How would this code, this is the code that I wrote earlier, how is this code different from task.run?
We don't need to start the task manually. It will
Correct.
start
Correct.
that.
So when you say task.run, it does both for you. It creates a task object, and it also immediately runs this for you, runs the code immediately. You do not have to do a task.start. It's immediately starting running it. So if you don't want to have a two-step process, you want to directly start it off, do it with task.run. If you want to have a two-step process, maybe you create the task initially, and at a later point of time, when something happens, that's when you run it. Then you can do it accordingly. Are we clear on this? So that's the difference between these two. Now there's an alternate option also available here, which is task.factory.startNew. And task.factory.startNew is similar to task.run. In what way? What is this? How is this similar?
Creation and starting at same line.
Single line.
So it immediately starts off. It immediately starts. So it doesn't have to do it, doesn't have to be started later at a later point of time. But there is one difference which we'll see in a little later code. At this point, they appear similar. But there is a difference between the way in which you call this code and how it works differently. So again, this code again would work same way. So I'm starting function 1 with task.run, but function 2 with task.factory.startNew. And let's try running this again. Right. So you had the first and the second function being called out here. Similar code as before. All right. Let's move away from this example and try a slightly different one. So I'd like you to see this and tell me what is different in this. How is this function different from the previous one? Yes. How is function 1 different from the previous one? I don't want to show you that, but you see this function 1.
So parameters.
And see this function 1. So you'll find that this function has parameters. So this is like what if I have to compare it with threads. If I have to compare it with the thread class, what is this like? Using what? You had two different, when you create a thread, you had two different parameters that you can pass. So what are the two parameters called for a thread? First is called thread start. Second one is called parameterized thread start. So which one is this similar to? This is similar to the parameterized thread start, wherein you can pass it an object. Now remember, you can pass it only one object. You can't pass it. You can't say I want to pass 2 parameters, 3 parameters. I can't do that. Okay. Only one object, and the signature will always be of type object. We discussed yesterday how you could have multiple values being passed out here, either using an object array or using an array list or creating your own custom class or keeping it as a, either as a local function or as an anonymous method. So we talked about that yesterday. I'm sure you have tried that code in the lab yesterday. Right? Whatever methods that we have discussed in class, I'm 100% confident that you all have tried that. Okay. I have that, I know for sure that when I say something, you're definitely going to try that out. Okay. I'm in a sarcastic mood today, but that's okay. So let's have a look at the same thing out here. We are calling this method. Now, instead of using action out here, what will I be forced to use to call that method? What will I be forced to use to call that method? Action of object, because that's the function that you want to call. And this is what I could do in my code. This is what I could do in my code. You first create an action of object and pass it to new task. See the overload it takes. What are the overload it takes? One of the overloads it takes is what? Takes an action of object as a parameter. And the second one is object state. So what is this object state? Object state is the value that you're passing to it. So I'm passing what? AAA to it. AAA would be received here as object. Are we clear on this, everybody? This is what we're doing. Right? And how do we call this method now? We're not calling it. How do we call it? I don't think, okay, I've called it here later. So you call it with t1.start. So this is what we're doing. That's the first possibility. Second possibility is also, you don't give in action object explicitly. You don't give in action object explicitly. But you directly give in what? The name of the function that you want to call with the parameters. But when you're doing this, remember that it is actually internally creating an action object. Okay. So that's how you could call it. This is the first possibility. Second possibility is, let's look at task.factory.startNew. And task.factory.startNew also takes what? An overload which takes a action object and the object state. What is the object state? What is the object state? What is the second parameter? Yes.
The one which we are passing.
The value that you pass to that function. So either you can explicitly create an action object and pass it that action object, or directly, simpler code is what? To call it directly with the function name. Now, I prefer showing you this code so that you know that this is what is actually being used out here. Are we clear on this? Everybody? All right. Now, here is where there is a difference between task.run and task.factory.startNew. Task.run cannot be used for calling a function that has an object as a parameter. So what's the basic difference between task.run and task.factory.startNew? Task.factory.startNew works both ways, but task.run works only with one way, only with functions that don't have a parameter. So what do we do then? In this case, see what I'm doing out here. I'm calling task.run. What am I passing here to it? What is the delegate of something? What is this?
Anonymous function.
An anonymous method, anonymous function. And if I have the anonymous method, then I can if I have the anonymous method, then what are the advantages of the anonymous method? Well, we've been saying this since day one. What are the benefit that you get?
We can use local functions, local variables.
Variables, correct. So variables declared in here now can be accessed by the anonymous method. So you don't need to worry about passing it. So if you insist on doing this with task.run, then this is the workaround to it. Otherwise, task.factory.start new is equipped to work with, to call functions that have parameters. Are we clear on this, everybody? So this is what we've done. So far, what have we tried out? Calling functions whose return type is void and who may or may not have parameters. Questions, if any? All of this code would be really easy if you have tried out the threading examples. Then you can relate to what I am saying. If by chance, for whatever reason, you have not finished trying the threading examples, then this looks quite complex because this is actually a wrapper class for threads. So if you're not aware of threading, then this becomes a little more difficult to understand. Questions, if any, with this? So if you want me to call that code, I'll call that. I'm calling function 1. I'm calling just this single line that's happening here, console.writeLine s, where I'm displaying the value for that s. And in the second case, I'm calling task.factory.start. So T1 is being started here. T2, of course, is started here itself. Task.run, this is being started here itself. Right. So these are the 3 things that were called out. Are we clear on this, everybody? All right. What have we not done in this so far? What are the, what have we been going around? What have we not tried out here?
Synchronization?
No, not synchronization. I'm talking about calling the function. What type of functions have we been calling so far? All our functions so far have been what?
Static.
We are not for instance.
Void return type.
Without return type.
Return type of void. Okay. When you use threading, threads when you use, could you call a function that had a return type other than void?
No.
So we had in threads also, we had access to only functions that did not have a return type. But now here with tasks, this is now the additional thing that you can do here, which you could not do with threads, which is it allows you to call functions that have a return value. Your function now could have a return value. What would change here? What would change here? First change that you would have is what?
Action will change.
Delegate type.
Okay. Okay. So if action changes to what?
Func.
To func. Right? Let's see how this changes. Let's see, instead of this asking you to look at this, let's see what all changes here. So first thing is, I have this. So what is this doing now? Function is returning an integer. That's the first change that I have. Okay, I'll make it smaller iterations. I'm not interested in showing you too many iterations. So what is this actually returning here? In one case, it's returning 10. When I becomes 10, it comes out. In the other case, I'll return 20. Let's say. So this returns 20. Right? Now, first thing that you have mentioned correctly is that action has changed to func. Action has changed to func. But see what it takes out here as a parameter. Here, you'll find that the task also has changed. The task also has changed. And here, what are you giving in this case? Task of something, right? Task of something. And this here is what is the return type of the function that you want to call from that task. So what is the return type of that function here in this case? We're calling a int out here. So task of int, whatever, t1 is equal to new task of int, and see what it takes as a parameter. See what it takes as a parameter. It says func of int. It takes func of int. Now see whether you got a overload to this. What is it giving you here? What is the other overload that it's giving you here? Func of object comma int. So these are the only two overloads that you have. Either func of int or func of object comma int. What does func of int mean? What does func of int mean?
No parameter, return type int.
Correct. So you can call a function that does not have any parameters and returns an int. Why does it make it int out here? Why? Normally you have func of t, right? Why has it made it int? Why has it made it int? Why has it made it only int? Why has it made it only int? Come on. Look at the line, no? What am I writing? I'm saying task of int.
Int
Task.
mention.
Correct. So if I'm saying task of int, then it will hard code it, or it will force you to use what? Func of int. Supposing I had said task of string. Task of string. What will this now change to? What will this change to? If you look at this, changes to what? Func of string. Based on what you're giving in your task, the func that you're giving also would need to have the same data type. And what is this? This is actually giving the return value. So task of return value is equal to func of return value. Are we clear on this, everybody? All right, so I'll keep it back to an int because I had written my function as an int. So I could now do func of, int, for a new func of int. And what will this take as a parameter? The name of the function that you're giving out. Are we clear on this, everybody? So this is what you could, what is it? Func1, is it? Func1. This is what you could do to refer to it. I've given you alternate syntaxes to refer to it. Either refer to it this way or explicitly do what? Or explicitly create a func object and pass that func object. Or third possibility is directly what? Simplest option. What do you directly do? What are we doing directly out here? Just giving the function name.
Function names by creating.
Right? So any of the syntaxes. Now the reason I'm specifically saying this is because different books, different, maybe articles that you read, and also different people whose code you read might write it in one of the three ways. So be aware that all three of them are doing exactly the same. And then you call it task.stat. So this is the first way of doing this. Are we clear on this, everybody? This is what you could do for calling that code. All right. Now, what if that function had a parameter? So this function doesn't have a parameter. What if the function had a parameter? the only parameter that you can give to the function is an object. You cannot give anything else. So just like this, like the earlier code, for this also, what were we doing? The only parameter that you can give here is what? An object. You cannot give anything else. So it can be only one parameter of type object, and that's my second function. So what would I use for the second function? For the second function, I'll use what? Func of object comma int. obj2 is equal to func2. And create a task of int and pass it obj func2. This is what we're doing. Alternate syntax. Alternate syntax. Alternate syntax, what will I do out here? Instead of obj func2, what will I do now? Directly func2. Okay, and then pass it a value. So look at this. This one didn't take a value. This one took a value. But when you're doing this code, internally, it's using this. And when you're doing this code, internally, it's using this. So see the difference out here. Can I have something other than object here in func? For this example, can I take something other than object? Can it return? Can it be a parameter of type integer? Yes or no?
Yes.
Answer is no. What did we say? That these functions that you're giving here, what are the parameter that you can have? It can only be of type
Object.
So this will always be func of object comma whatever the return type. Return type can be anything. But the first parameter here will always be object if at all you're giving something. So now what can I pass to the object? Can I pass an integer to the object? Yes.
Yes, sir.
Can I pass a string to it?
Yes.
Can I pass a object of type employee to it?
Yes.
Yes.
Can I pass two parameters to it? In what
No.
way will I pass two parameters?
Anonymous flag.
The different methods that we discussed earlier. Either pass an array list or an object of arrays, or create your own class, have properties in there and then pass that, or keep it as an anonymous method. So all of those things that we've been trying yesterday, which you all have tried yesterday, which you all know already, which you all are very good at, you all have practiced it so well yesterday. Those same fundas are applicable today, right? So do practice. The point I'm making here is that, I build on concepts. When I'm training you, I say, okay, if you know the earlier one, then we can do the next step. So please try out coding. I know you all had 5 o'clock, you all had some other lab or some other activity and all of that. But after the activity is over, after everything is over, for your next day class, it is important that you try it. Okay, so this is what we are doing. What if I had to call it with task.factory.startNew? Okay, before I do that, I didn't show you the code for this. So now we are starting this with t1.start. We're starting this with t1.start. I forgot entirely about this. We have to get the return value. Correct? In threading, did we have this problem? Did we face this problem in threading of having to get the return value with system.threading? Did we face this problem of having to get the return value?
No, sir.
No, sir.
Why not?
Because
Because thread doesn't return any value.
Because all the options that you had with threads, all of the functions had a void return type. But somewhere else we had this problem. Where did we have this problem of getting the return value? Somewhere else where you're calling code asynchronously, where you wanted to get the return value, you had a problem. Where else? How else can you call code asynchronously? One is using threads. What else?
So begin invoke.
Yeah, with delegate.begin invoke. And there, what did you use?
Wait callback.
A callback function. All right. It was a function. It was a delegate called async callback. So you use async callback there to get the return value. Now here, you're not using a callback function. You're not using one. Instead, to get the return value, you're directly getting it with t1.result. You get directly getting it with t1.result. Now this t1.result will give you the return type from this function. So what is this function returning right now? The return type here is what? Is int. So t1.result right now is returning an int. If this function changes and if it doesn't return an int, some other value, then t1.result will return that value accordingly. Okay. But there is a problem. And what is the problem? What is the issue with writing this line of code? What is the issue with writing this line of code? Line 151. When can we get a return value?
So only when T1 is completed.
Only after T1 has finished execution. Right? Now in threading, how did we ensure that you should write code only after a function finishes execution? Supposing you're calling a function in a thread, how did you ensure that you keep waiting for that function to get over? In threading, what did you do?
Join.
Thread.join. Now, instead of a thread.join there, in a task, this is task.wait. So your task.wait is similar to a thread.join. It's a waiting call. Waiting for what? Waiting for what? T1.wait is waiting for what? Waiting for what?
You want to complete it
For that thread, for that task. Let's use the word task. It's actually a thread, so I know what you're saying is right. But let's use the word task. Waiting for the task to finish.
complete it execution.
Right? And I want to call this T1.wait only if what? Only if what? If T1 is not completed. So if T1 is not completed, if you'd like to write some code, you can do this. So this is a property called is completed, and I'm doing a not on it. So if it is not completed, then wait. And after it has finished waiting, then what are we doing now? Getting the result. Similarly, T2, get the result after it has finished. Are we clear on this, everybody? So this is the style of coding that we'll be writing out here. This doesn't have the callback function mechanism that was there in delegates. Delegates had that mechanism of a callback function. Here, you keep a check for whether it is over or not. Are we clear on this, everybody? Questions, if any? So if you look at, let me run this code. If you look at this code, T1 is being started, T2 is being started, and wait for the result to come, and then call T1 and T2.result. Right? And whatever, 10 and 20 is what is being shown out here. Are we clear on this, everybody? All right. So for you to try out, you have a task.factory.start new. So you'll find that there are two start news out here. What are the two start news? What are the two ones for?
So generic and non-generic.
Non-generic.
So what are the generic one doing? Hmm. Hmm. What is the generic one doing?
Specifically for any type.
Basically for
Specifically for any type.
what type? What are we talking about here?
Returning value.
Correct. So look at this. Start new of whatever, let's say int, and see what it takes the parameter now. What does it take here? A func of int.
Complete.
Are we getting this, everybody? So whatever you're given in there. So you have to try doing this. In fact, I've given you the code already. I didn't want to do that, but I ended up explaining the whole thing to you. So try calling it with start new. Okay. I'm not giving you the code for this. To do. Try calling function with return value with which one are we using? Which are the two methods that I'm asking you to try out here?
Just start.
Right? So see whether you can do it with task.run. See whether task.run has an option of doing the same thing. Do you have that? Task.run with angle bracket. So try that out. This is for you to do in the lab. Okay. And then of course get the return value also. So these are the things that you do with tasks. Okay. So now I've presented you with 3 different scenarios for calling asynchronous code. What are the 3 scenarios? First, we called it with delegates. Secondly, we called it with threads. Thirdly, we called it with tasks. Now, let me, you can note down these differences when you would use that. If you had functions returning a value, then between delegates and threads, which can you use? Which is the only thing you can use between delegates and threads?
Delegate.
Only you could use delegates with delegate.begin invoke. Okay. I'm not talking about tasks. I'm talking about threads and delegates comparison. What if you wanted more control on your thread? Then what would you use between delegates and threads?
Threads.
Threads, because you then have more options available by creating an object of the thread class. All right. Now enter the task. Can task do the same thing that we did with delegates, which is calling a function which returned a value? Could we do that with tasks? Yes. So task
Yes.
can be used to supplement that. All right. The mechanism is different. Those delegates use the callback function. Here you're using what? How are you getting it? With the task.result and checking for doing a task.wait and all of this. So the mechanism is different. The way in which you did it is different. Okay. Now there is a major difference between delegates and tasks. The delegates, not all delegates. I'm talking about the async code with delegates. That async code with delegates is not supported in .NET Core. .NET Core has delegates. But what does it .NET Core not have? What does it not have? What methods are you calling there?
Begin invoke
And
end invoke.
and end. So that mechanism of begin invoke and end invoke will not work in .NET Core. So there your only option available there is what? Task works in .NET Core. So what is the only option available there in .NET Core?
Thread and tasks.
Would be threads and tasks. Okay. For calling code asynchronously. All right. Now between thread and tasks have come in later, and tasks we said are firstly they are considered to be a wrapper on the thread class and an improvement on the thread class in terms of features that it has. Secondly, tasks are also considered lighter in terms of system resources compared to the thread class. So the preferred option that you would be using in here would be working with tasks. Are we getting this? Because they sort of fit everywhere. Others had ifs and buts out there. But tasks are a more standard way of coding. So going ahead, all the code that we use, which is going to be async in nature, we'll be using it with tasks. Are we clear on this? Questions, if any? All right. So I'm not done with tasks. I'm going to show you a couple of more things that you work with when you're working with tasks. So let's have a look at this. All right. Now, I'm going to use a concept called as await, and associated with await is async. Okay. Now, we have seen this in just the previous example that to read a value from a function that returns a value, if you wanted to get the value, what did you need to do? In our code, what did we need to do?
Wait for the thread to finish completion.
Okay, and then get the result. Okay. Now this is something that you will require quite often, right? Now instead of every time having to write code like this, instead of having to write these 3 lines of code in this manner, if you had to wait for that function to finish execution and to get the return value, this can be done in a shorter amount of code. And in this case, to do that, you're going to use the await keyword. So what does await allow you to do? What does await allow you to do? Allows you to get a value from a function that is returning a value. Right? So you don't need to call thread.wait now in that case. Instead of that, what you can use this await syntax to get in the value. So let's see an example of await. Let's see an example of await. Before I show you the function and blow you away, let me just show you how this code is being written here. So I'm saying I'm calling before. Okay, before that function. Now I want to call do work async. The method that I'm calling called do work async. But this method returns a value. this method returns a value. I'll show you what the return value is. Don't, if I right now show it to you, you will throw something at me from your screen. So this method is returning a value. In this case, is returning a string value. Now this here is a waiting call. Waiting call indicating what? Unless it finishes, you will not be able to go to the next line of code. Okay. But it is running it on a separate thread. So two things are happening. It is running it on a separate thread. When you're saying, it's a new task that is being created, it's running it on a separate thread, but you're also waiting for that thread to complete. So it's not going to go on to line number 17, 18, and 19 unless it finishes this line. Okay. Now you might say first reaction of yours might be, is this then a synchronous call? What happens in a synchronous call? What is happening on a synchronous call?
Main thread waits for other threads to finish.
Correct. So you're waiting for that. So from that sense, it works like a synchronous call. But in a synchronous call, typically all your code is running on one thread only. Here, when you're calling it with await, it is actually running it on a separate thread. So there's a difference. Instead of running it on one thread with a synchronous call, await is running it on a separate thread. So what is the prerequisite if you have to run it on a separate thread? It needs to be run as a task, right? Either as a thread or a task. And we're saying we're going to be using tasks. So it needs to be run as a task. So you cannot call any method with await. You cannot call any method with await. That method should return a task. Are you understanding why are we saying that method should return a task? Why should it return a task? Why should it return a task? Yes. Why should a method that you're calling with await have to return a task? Why can't it be any other method, any regular method?
Because it's running on a separate thread.
Very good. That is the answer. Because we want to run it on a separate thread. So if you have to run it on a separate thread, it needs a task. Are you clear on this, everybody? So the question that comes up is, what is the benefit of doing this? It's anyway waiting. It's anyway waiting. So why not run it on the main thread only? Right now, what's going to happen on line number 16? What is it going to do? It's going to create another thread and run that do work casing on a different thread and not on the main thread. So what would be the benefit of doing this? What is the benefit of doing this? The benefit of doing this is now that the main thread is not blocked anymore. Earlier, what is happening is if you ran it on the same thread in a synchronous manner, if the main thread is doing some work, that main thread gets blocked. Are we getting this, everybody? Let's assume, I'm just giving you an example. Let's assume I want to write 4 lines. I want to write 4 lines. Okay. One possibility is I write those 4 lines myself. I write 4 lines myself. But while I'm writing those lines, I cannot be teaching you. I can do only one task at one time. So if I'm writing, I'll say, okay, wait, don't do anything else. So that was a synchronous call. So running on a single thread. I'm writing some. So I took a session. Now I'm writing some code. So while I'm writing the code, you're all waiting for that task, for that code to finish, or for those 4 lines to finish. Only after I finish those 4 lines, now I can then continue with the session. Now, on the other hand, what I can do is I can tell Kaustubh, please write those 4 lines for me. Right? Now I'm waiting for Kaustubh to finish writing those 4 lines. I'm waiting for him. Okay. But in this waiting time, I am not blocked. What can I do in this waiting time? What can I do in this waiting time? I'm asking Kaustubh to write some code for me. I'm not continuing with the session, but I'm asking Kaustubh to write it. But what can I do now in this waiting time? While Kaustubh is writing those 4 lines, what can I do? Yes, I can drink water. Yes or no? Otherwise, if I was talking, I could not have done that. So there is a difference between the two. I'm asking some other thread to do it for me, and I am free to do other things. Now, this concept is very important when you have a UI. When you have a UI, the UI has a main thread running. And let's assume you call some code. You call some code. Now, when you call that code, the main thread, the main UI thread will be blocked for any other operations. It will not be able to do anything else. It won't be able to do anything else. Why won't it be able to do anything else? Because it is performing some task. Right? Now, instead of this, in the UI, if I run it with await, what will happen now? That code that I'm running will run on a separate thread, and the UI thread will be free for performing any actions. Let's say he wants to move a window. To move a window, the earlier case, he will not be able to move it if it's running on one single thread, because the system is busy doing some code. But if that code that he was writing was in a different call with an await, the main thread is now free for performing any UI actions. So this is where it actually makes a lot of difference. So await is a big benefit, especially in code where you have UIs. Which code have we seen which has a UI? Which code have we seen which has a UI? Console app doesn't have a UI.
WinForm.
Yeah, WinForms is an example of that. Are we clear? So there it makes a lot of difference. Not so much here in the console app. Are we clear on how await is different from await is a waiting call that does not block the main thread, as opposed to a synchronous code which will block the main thread. Clear? Are we clear on this?
Yes, sir.
Okay, because the code is very simple. The code is throwaway code. This is a hello world type code that I'm doing. But it's more important to understand where you need to use await. So where would you be mainly getting the benefit of await is in UIs, where it doesn't block the main UI thread, the code that you're calling. Now let's look at the code. Now let's go into the code. What did we say? Await, what functions can we call? For that await to work, what is the prerequisite? Function needs to return a task. So see what my function is returning. What is it returning here? It's not returning a string, it's returning a task of
string.
Are we getting it? Because it has to call that code from there. And what is this code now doing here? In this case, return what? What am I doing here? Task.run is starting off a new task. Starting off a new task. Remember? Task.run in one of the previous examples we've taken it. So what is this function doing? I've used the anonymous method here. What is this function doing out here? 5-second delay, and done with work. So this return done with work is going to come back here. You're going to return it from here and get the value in here as a waiting call. As a waiting call. So how would the output go? Will after be shown immediately? Will you get before, immediately after, and then after some time will you get the message? Is that how this will run? Or will it say before, then wait for the message to be displayed and only then call after? How will it run?
So wait for the message to display.
Correct. We have been saying all along, we've been talking all along, this is a waiting call. Let's try running this. Right. So before, and then there's a 5-second delay that's happening. And then done with work, and then the after. But what is the major difference between a synchronous and the async code with await is that this function ran on a separate thread and did not block the main thread. Very useful in UIs.
Sir,
Yes.
but sir, during this time, main thread is remaining idle. So what is
Yes.
the use of running on that?
That's what I'm saying. That is the previous statement is mainly used in UIs. This feature will mainly be used in UIs so that the main thread is now free to do a UI operation. UI operation could be in something like minimizing a window, maximizing it, moving a window, resizing the window. These are the UI operations. If this was synchronous code without await, the main thread would be blocked. That is what I'm trying to say. That is exactly the point I'm making. Understood?
Yes, sir.
Unfortunately for you all don't have WinForms in your course. We're not going to do WinForms. So I cannot, I'll show it to you, sir. I'll show it to you still. But what I'm trying to say is that, I cannot really get into WinForms example. I'm showing you snippets, a hello world example here and there, explaining to you, but I cannot get into WinForms. I don't have the time. I'm already way over time. If Nisha is listening, I'm already way over time. I've taken more than what I should take already. Anyway, coming back to this. So this is the first thing that we tried out. Are we clear on this, everybody? Are we clear on what has happened here? Any questions about this? Now, there are a few more things that you have to have. All right. A few more things that you are having. What are we writing in here? We are writing an await in here. Where else are we writing an await? Where else are we writing an await? We're writing an await in here. Okay. Whenever you write an await, the await has to be put into a function marked as async. So this is a prerequisite. If you got an await in your function, then the function must be marked as async. Otherwise, it gives you a compilation error saying that you cannot call await. What is the error now showing up here? Why is it showing up the error here? What is it saying? What is the error? That await, where is it? Await can only be used within an async method. Are we clear on this, everybody? So this is what we are doing. Okay. Where else are we using await? Where else are we using await? In the main also we are using await. So main has to be also marked as async. Now that gives me another problem. If I got a method which is async, I can't keep it void. I can't keep it void. This gives me a compilation error. Right? This gives me a compilation error. So it says the error is program does not contain a static main suitable for an entry point, but more information is being shown here. a void or an int returning entry point cannot be async. So main which is void, a main which is void cannot be async. Are you getting what I'm trying to say? So there's another conflict here, which is what async cannot be given in combination with void or this thing. So what do you have to do? You have to return a task out here. And that's how the code would compile. Are we clear on this, everybody? So this is how you ran the code. So await and async are given together. If you got an async in a method, the method must be marked. Sorry, if you got an await in the method must be marked as async out here. Are we clear on this, everybody?
So
Yes.
So what is the task on line 13 returning to, as in, like, where is it returning to?
It's
Because
not written. Does this task return anything? What do you use task for? What do you use task for?
to run a thread, I mean, like,
What is the, there are two types of tasks. No? Two types of tasks. This task is a function returning a value. And what is this task? What are you going to use with this? For functions that don't have a return value, that have a void return value, use this task.
okay.
Okay. So which
So,
is why
but then the task is basically we are assigning something and it is,
it's just a thread that's running. A task is a thread. So your
yeah,
main thread is also a thread, no?
correct. So
Is it-
when will this task run?
When does main run?
Okay, so the both will be running at the same time.
This is a separate thread.
Yes.
Isn't that what we have been saying, right? Main thread runs on one thread. So isn't the main thread also a thread?
Yes.
That's what I'm marking it. Why am I forced to? So far, I've never marked it like that. Why am I forced to mark it like that? The problem is with async. Async says I cannot have a void or a int return type. I can't have that. Main can be either return type, can be either void or int. Async says I can't have it void or int. I will not accept it. So therefore, I had to change main to task. What if I removed async? If I removed async, I could have had main as void. But what happens when I remove async? What is the problem now?
We can't write await in main method.
Exactly. So await is now complaining. Await is saying, where is my async?
So,
Because you gave a await, you are forced to write an async. And async cannot be called with methods that have a void return type. So you are now forced to make it a task.
so does this, like, does this task do anything or just there?
Just there.
Okay.
Okay, now I'll tell you some more fun. They realize this problem later. Developers started complaining, what is this? Like you only, developers like you only. Why am I writing tasks? What is the meaning of tasks? Why should I have to write tasks? Without realizing that you are actually running a thread only. The main is also running on a thread only, right? The main thread. So they have removed this in .NET Core. So in .NET Core, you can have async with void main. But we are doing it in framework. So you're forced to write a task. All right. So I get your point. Why am I forced to write a task? Microsoft also got your point and they listen to you in Core. Your point made by so many other developers. Okay. Your problem is y'all are, expected to learn what has happened over 20 years in 12 days. That is the problem. So anyway. We have tried this. The issue with this was, it was, await. Sorry. await was an alternative to the syntax that we wrote here. What are the syntax that we wrote here? What are the syntax that we wrote here?
So that mean like we will get the value only when the thread is finished. I mean
Yeah.
working.
So get the result right at the end. So because we didn't want to do this, we were using await. But await has its own idiosyncrasies, which is what is the problem with await? What is the issue with await? It's going to perform a blocking call. And then async, await must come with async. So all those things that we just discussed. So I'm just showing you, if I had to call now this method, the same method, if I had to call it the other way. Now see what I'm doing here. Now I'm not performing a blocking task. I'm not doing a blocking code out here. So what am I doing here? I'm calling it with t1.stat. I'm not doing a blocking code here. So what will this do now in this case? It will show you before. T1.start is doing what? Started on a separate thread. And what happens now? What happens now? Immediately after that is what? You're continuing with your other code in main. Complete all the other code in main. But at some point, you have to do a blocking call. At some point, you have to do a blocking call. Yes or no? Even this code that we had, where were we doing a blocking call? Tell me. In this code, where were we doing a blocking call?
Line 146.
146, where you're doing a wait. So why are we doing a blocking call? Because we are saying unless the function is over, we can't get the return value. So blocking call is required, unavoidable. They are not using the other pattern. What is the other pattern that they could have used? Which we use in delegates. What are the other pattern that they use there?
Callback.
Callback function. They're not using callbacks here. Right? And there are technical reasons why they're not using callbacks. I don't want to get into that right now. So they're not using callbacks. So because they're not using callbacks, you're forced to use a blocking call. Now, either use a blocking call while calling the function. Either do that. Or look at this other option. What am I doing? Call the function without a blocking call. Then complete all your other code. And to get the result, do it with await. So what are we doing with await now? We are not calling the function with await. What are we calling with await?
Result.
The result. So it's waiting for that result to be called out. Are we clear on this, everybody? This is again a blocking call. That means it will not go to the next line. It will not go to line 40 until what? The result is got out here. So if you want, you can write code in this manner. Call the function separately and await the result separately. Are we clear on this, everybody?
So second option will be better, right?
Not necessarily. There will be, see, why are options given? If only one option was good all the time, then they will give you only one option. Options are given because you need options. So both options are available to you.
So
it's not compulsory that you might want to run this here. Like I said, I gave you the example of a UI call. I want to perform a task, but I don't want to block the main thread. Are you getting this? I want to perform a task, but I don't want to, block the main thread. So I want it to be synchronous, but without blocking the main thread. So use the first method. You don't have to then do it in 2 steps. Here you're forced to write it in 2 steps. So I started off my discussion by saying instead of doing it in 3 steps, you do it in 1 step. That's what my discussion start was. So don't generalize by saying that, oh, always use this. There will be situations where you need the first one also. So let's try the second one. And the difference now in the second one, of course, would be what? What would this be different? How would it be different before? Then you started off on a separate thread. And then what? Then what? After runs, immediately. And then you wait for the result. Okay. So, sorry, the main is not marked. Let's run this. And before, after, immediately. This is like you got in the delegates. And then 5 seconds later, you got the return time. Are we clear on this? All right. Now, this style of coding with tasks, await, async is going to be used a lot. So you will find, especially if you're writing .NET Core, in .NET Core, the preferred option here will be tasks and how you're working with tasks with .NET Core. Okay, so there will be a lot of async, await out there as well. So do try this out and get comfortable with this, because these are not concepts that are going to go away. It is not ki, haan, theek hai, chalo, we have studied for the exam and go on. All your further code that you write, which is going to be asynchronous in nature, is going to use these concepts that you use in delegates, concepts that you use in threads, and concepts that you're using in tasks. So if you want to be a good programmer, you need to know this. All right. I am not concerned with your exam. I am least concerned with your exam. My objective is to make you program well. If you can program well, you can crack any exam that you have. So be a good programmer, try out these things. I purposely was asking you how many of you all have tried that code in threading, because I know you all have not done it, because 5 o'clock you would have gone into that other lab session and then forgotten about .NET. And then you all also had a project and then whatever other activities that you all are busy with. So please try this out. Okay. Questions, doubts, if any? All right, so let's move on to the next example. There are some leftovers, as I call them, okay, which is language features or things that are there in C#, but which I have not covered them because I don't find them important. Not because they are not important, because I generally tend to focus on the more important areas that you're going to need in your code frequently. Those are things that I generally focus on. But this is also there as part of the C# syntaxes. So let's try and see what these are, how these work. Okay. The first thing I'm going to be talking about here is operator overloading. So operator overloading is again a concept that you would have probably learned in C++ also, all right, and is available to you here as well. So what is operator overloading dealing with? Typically, when you have certain inbuilt operators, like you might have let's say A plus B. So here A is an operator you are using for any calculations, for example. Or if you're saying if A greater than B, you have relational operators again out there, greater than, less than, greater than, equal to, and so on and so forth. So you have certain inbuilt operators that are defined out here. Now these operators know how to work with basic data types. So for example, if I said int A comma B. All right. And let's say B is equal to 10, for example. And if I said A is equal to A plus B, this knows how to work with this. Or if I said A is equal to A plus 5, whatever. The inbuilt operators know how to work with these data types. So what are the two operands that you have here? The operator that you're using is plus. What are the two operands? Operands are, yeah. And what are the data type of these operands?
Int.
Both of them are an int right now. So when your operands are inbuilt data types, then the compiler knows how to work with it. But if your operands are going to be, custom classes that you create, let's say employee O1 equal to new employee, for example. Okay. And if I had to do something like this, O1 is equal to O1 plus 5. Now, what are the two operands out here for the plus? First operand is what? First operand is of type
Employee.
right? And here the second operand is of type integer. Now, the moment you are faced with a situation like this, the compiler does not know what to do. It does not know how to handle this situation. Now, what if you want to tell the compiler that, okay, if this situation comes up, this is what I want you to do. This is how I want you to use when you use the plus operator. And if I use it with my operand, this is what I want you to understand. In this case, you are overloading the plus operator. What are we doing here in this case? When you're telling the compiler how to work with the plus operator for my class, you're overloading the plus operator for my class. So that is what operator overloading is all about. How to make existing operators, all right? How do you make these work with my class? That's what this whole operator overloading is all about. Okay. And as I said, you have done this in C++. Now, I'm going to take C++ as a standard option out here. And if you took this line in C++, this line was understood by the compiler as, this part here was understood by the compiler as O1 dot operator plus into bracket 5. So the compiler converted in C++. I'm talking about in C++. The compiler converted this line O1.5 into what? Into what? O1 dot operator plus into bracket 5. So in C++, if you had to make this work, what is O1 now? O1, you can think of it as a reference of your class type. What is this now? What does this look like? What does this look like? What is operator plus now in this case? What does it look like? A method. So this method takes what as a parameter? What is the data type of this method, parameter of this method? Integer. So you had to write a function in C++ called operator plus in your class, which took an integer as a parameter. That is what you needed to do to make it work in C++. Now in .NET, this is different. When you write this line as O1 plus 5, this converts it in .NET to employee dot operator plus into bracket O1, 5. This is what happens in .NET. This statement is converted into what? What is employee here? Employee is what?
Custom class we made.
Class name, operator plus into bracket O1, 5. So what does this look like? What does this look like? When you're saying class name dot method name, what does that mean?
Static method.
Static method.
Correct. So to make this work, to make your compiler understand your code, what you would need to do is you will have to write a static method called operator plus in your class. And what would be the parameters of this method? What will be the parameters of this method? What is the first parameter?
Object.
Object of what type?
Employee.
Employee. And second parameter?
Integer.
Integer. Are we clear on this, everybody? So this is how you can write your own implementation of the operator plus. What are we doing here? We are overloading the plus operator. We are overloading the plus operator. This is what we need to do. Are we clear on this, everybody? Yes?
Yes, sir.
Now the second question. What should happen when you add 5 to an employee? What are we trying to do? We're trying to add 5 to an employee. Yes or no?
Yes, sir.
So what should happen in this case? What is the correct answer?
So we'll have to define.
There is no correct answer. There is no correct answer. What to do that I cannot tell you. What to do in there, I cannot tell you that. That you have to decide. Now, who are you? The person who is creating the class, the developer, correct? So what code to write in there is the job of the developer. What does he want to do? So if you create the employee class and you try to add 5 to it, now I'm asking you the question. Assuming you are the developer, and if you created this employee class and you are trying to add 5 to it, what do you think should happen? What do you want to happen?
Sir, if any value, the existing instance value, I'm adding the 5 in it.
So what do you want to do when you add 5 to an employee? I'm asking you. What do you want to do?
Return the value.
Huh?
Return value.
But how can you add 5 to an employee? Can you add 5 to an employee?
It is meaningless, sir.
So I am asking you to put meaning into it.
We will add 5 to one of its parameter.
And now remember, whatever answers that you're giving me, none of the answers are wrong. None of the answers are wrong. Why are none of the answers wrong?
Sir, because whatever we want, we can
That
do
is
it.
your class. No? Now what nonsense you do in your class is yours.
Yes, sir, correct.
If somebody says that when I add 5 to an employee, I want to increase his basic 5 times. That is your lookout. That's not my class. That is your class. Or you might say, I want to add 5 to the basic. Your lookout. Or I might say, I want to add 5% to the basic. Your lookout. Or I might say, add 5 to the department number. Your baby, not mine. Are we clear on this? So what you want to do in that class is up to the developer. Compiler simply says what? Compiler simply says what? If you want this code to, if you want this line of code to not give a compilation error, then you do what? What should you do now? What should you do now? What should the developer do?
Overload.
write a
A logic.
method, write a static method in the class which has this signature, and the code will work. Are we clear on this, everybody?
Yes, sir.
All right. So let's try out operator overloading. All right. Okay, let me create a new class and do this. Now you're going to help me with this. Public class 1, let's say. This is a public int I. Okay, so I'm keeping it fairly simple. If I tried creating this, if I try creating an object of this class 1 O is equal to new class 1, and if I did O dot I, not do dot I, sorry, O is equal to O plus 5. I'll take the same statement that I wrote some time back. Here it's protesting, saying what? What is it protesting? What is it protesting? Why is it saying that I cannot understand this? What are the reason?
The different data types.
So, because it doesn't understand how to work with this. So to eliminate the error, what do we need to do?
You have
What
to
we need?
overload the operator.
What function would we write? Help me with this. Public,
Public
yes.
static
Static.
operator.
Now, what is before the operator? What is this returning? Return type here is
Object.
what?
Object
Darling, don't say object. Say whatever. Class 1.
class
Returning class 1.
class, right?
Right? Okay. Public static class 1 return type, and the name of the function was operator plus. All right. What are the parameters that it will take? The two parameters it will take would be what? First parameter would be of what type? Don't say object. Don't say object.
Employee.
Class 1.
Here it's not called employee. I'm calling it class 1. So class 1, whatever. Let's say O, and second
Integer.
parameter of type
Integer.
Integer.
Int.
int I. Right. Now the moment I've written this function, this function giving an error because I have not returned a value as yet. But you'll notice that the compiler now accepts my code. Compiler says, okay, you have written that function, I'm okay with it. Are we getting this, everybody? Now let's write down the actual code. So now this is my class. So I will decide what I want to do. When you're writing your class, you all decide what you all want to do. Okay. Right now, let me decide what I want to do. So what I want to do is, I want to actually, when I pass 5 to it, I want to actually add 5 to that I out here. That's what I actually want to do. So help me with this. First thing is, I will say class 1, let's say return value is equal to new class 1. So this is what I'm returning. And at the end of this, return ret value. So I'm returning an object of that class. Okay. Help me with this code now. What should it do? So supposing here O dot I was 10 to begin with. O dot I was 10 to begin with. What should this become now? What should O dot I give you right now? What should O dot I give you right now? Yes. What do you
10.
think? Initially it was 10. I'm adding 5 to it. This should give you a 15. So that's the code I want to write. So help me with the code. What would I do out here?
So O dot I plus I.
Into what? Into store that into where?
O dot I.
Not O dot I.
Rate well.
Rate well.
Rate
Rate well.
Rate well here.
Oh, sorry.
Retval dot I is equal to O dot I plus
I
I, the variable I. That's what I'm actually doing. Are we getting this, everybody? So I'm getting the two objects out here. I'm picking up the I value from there, O dot I, and then the I itself, and returning that out. So now when you run this, this gives you the wrong output, wrong project. Okay. Operator overloading. Let's run this. And that gives you 15. Are we clear on this? So you got this code working. Now, what if you said, okay, I'm not saying it. What if you said, I don't want to do plus, I want to do into. I want to do into. Is this wrong code?
No.
Is this wrong
no
code?
sir. No sir.
What you want to do it is your lookout. Now, what will this give you actually? What is this giving you right now? 50. So how you want your code to behave is your lookout. But obviously don't do something so, drastic that if he tries to do a plus, you do a into. There's nothing wrong in this, but, make it work accordingly. Okay, I want this to work. Let's say I have O2. What I want to do here is, can I do this here itself? Okay, as so O is right now 15. O dot I is right now 15. What I want to do here is O is equal to O2 minus O. I want this to work. I want O is equal to O2 minus O to work. Right now, of course, it's not going to work. Right?
Yes sir.
Help me make it work. Help me make it work. You can look at the previous code and tell me what I need to do.
So we need to create static method.
Read out the
Public static
Hmm.
class one operator minus, and then the argument.
Then the arguments you're leaving it to me. You have to tell me, na?
Yes sir. Operator minus.
You do it. No, I will not tell you. You do it. I'm asking you for the answer, and you're saying no. Then you put the arguments. Come on.
Minus class 1 O comma int I.
Is this an int I?
Class
No,
1.
no.
No, sir.
No, class
Class-
1. Class 1.
Very
Class one
smart you
only.
are. That's why you are telling you do the arguments.
No sir, I can't. My mistake.
No, you're not mistaken. You're very smart. You do the argument means, okay, you tell us the right code. So this down here will not be a class. Will not be an int. This becomes what again now?
Sir,
What
class-
are the data type for the
class one.
Class
1 O2. Right.
Right? Okay. Again, code now. Who's going to give the code?
Class 1.
Come on. What would I do?
Class 1 red file
Carry
is
on.
equal to new class 1.
Right. And
Then red file dot I is equal to O1 dot I minus then O2 dot I.
perfect. Right. And then
And
of
then
course
return
return
that
that. Very good. So this is what you would do. Now remember, if you're using an employee class and you did employee 1 minus employee 2, supposing you're using the employee class and you did employee 1 minus employee 2, what do you want to do in that employee 1 minus employee 2? What should be the logic that you want to use? Supposing I'm asking a question to everybody. I'm saying that you did employee O1, employee O2. O1 is equal to O1 minus O2. So what should happen when you do O1 minus O2? What should you do? I'm asking you. Yes. What should it do? What do you want it to do?
So difference of salary.
Yes.
Into
Properties
the
can-
third object. Fine. Whatever. So the operator overloading is not very difficult to write down. But when do you need it is what you need to decide. In my class, do I want this operator to work with my class? And if it has to work, then this is the code that I want it to do. Or I did employee into 5. Employee O1. O1 is equal to O1 into 5. So what should O1 into 5 do? Right? What should it do? What it should do is entirely your lookup. That is what I'm trying to be telling you right from the beginning. Okay. Anyway, let's run this code and let's see whether what Naeem told us.
So one question.
Let me run the code and I'll come to your question. So what we had here was, okay, we got it as 15 minus, 20 minus 15, which gave you the value of 5. Yes. What's your question?
Sir, did we need to create a new object there? Can't we just return O?
What you do is your lookup.
Yeah, that's, you created a new object. That's why I wanted to ask.
Yeah. So remember this, that you can't change this value. This value will not change. You have to return something. Now, what you're returning, whether you want to make changes in that same O and then return it, is up to you. What you do is your code. It's easy for me to tell you operator overloading. If you ask me what should I do, I'm going to tell you your wish, whatever you want to do. Right? Okay. I'd like you to read up on operator overloading. There are a few nuances and few other things which I'm not covering it in detail. I cannot cover every possible topic in detail. All right. So I would like you to read up on that and see what operator overloading does. It gives you a list of operators that can be overloaded. Okay. Read all of these. And then there are certain, pros and cons, like, for example, okay, it's not given there, but so if you take up one of these operators, let's say greater than equal to, right? So there will be certain rules that are to be given out here. Okay. So for example, giving you that. Okay. So the comparison operator especially would have certain rules and you can actually check for that. Okay. So if a reference type overloads the equal to operator, use the object.reference equals method to check if references to the two type refer to the same object. So there will be certain nuances and rules given in all of these, right? And check out for those. So I'm not going into details of operator overloading, but I would like you to consult the documentation and read more examples or read more options with the same. Okay. All right. We are past our time, which is past 12. So let's quickly take a break and we will return after the break. Okay. 12:30, we start the session again. More examples to be done out here. For now, though, take a break. Okay, see you all at 12:30. the last topic that we had seen was operator overloading. Let's try another topic and going in for a new project. What we're going to look at next is an indexer. Okay. So if you look at, if you create an object of your class, and if you look at this object, you can access it directly with O dot or whatever. But an indexer allows us to access this object like an array. All right, like an array or a collection. So if you have an object of some class, the indexer is this, the square brackets, the subscript notation. And this is allowing you to convert your class or an object of your class and treat it like an array. Okay, that's essentially what an indexer does for you. Okay, so if you write code like this, now this is not an array. Class 1 O is not an array. But I'm saying the indexer is allowing you to treat it like an array. And I could do something like this. Like, for example, I could write code like this. O of 0, for example, is equal to some value. O of 1 is equal to some other value, and so on and so forth. Right? So in C++, for example, you could overload the square brackets. The square brackets, the array operator was also considered as operator overloading. But here now in .NET, this is referred to as an indexer. So if you look at this syntax, you'll find that the syntax out here is similar to what you use for a property. For a property also, what were you doing? You were, assigning it a value, or somewhere later you were doing a console.writeLine and you were trying to read a value from there. Okay. So in this case, for a property, this actually called your set, and this is actually called your get. And the same thing is true for an indexer. So if I have to write an indexer for my own class, if this is my class 1, how do you write the property? If you look at this, how do you write a property? If for example, if you had said O dot X equal to something, if you had done this, what would your property look like? How would your property look like? Give me the code for that. Public int X, right? And then you would have the get or the set. Why don't I just write it down in my Visual Studio? It will be easier for me, the curly brackets and all of that. Let's say if I had public class 1. And I'm saying I created a property here. So public int X, for example, and this would have my own get and a set. Right? This will have a get and a set, and I'll come back to the code for the get and the set later. Now, instead of a property, what are we having here? Instead of this syntax, we are having what? This syntax. So what are the name of the property here? Does this have a name? O dot, does it have any name? Yes, no. Does
O dot O of X?
O of X, but does it have a name for the property? For this one, is there any name? O of X is correct, but there's no name for that property, correct? So here, this is how it would look. You would say public int, and if you look at O, what is O? O is the current object. So the current object is represented as this. So public int, instead of property name, you are saying public int this, and after which you need what? After which you need what? The index out there. So the index here is of type int. So int I, for example. And this is how you would actually write an indexer for this. Okay. This is how you write an indexer for this. So did you figure out how I got to this public int? It didn't have a name of the property. Instead of the name of the property, it had what? It had the current object itself. So which I got it as this. And then the index for this has come in this way, int I. And this, of course, has its own get and its own set. We'll write down the code for that in a minute. But this is what you could do. Are we clear on this? Okay, so by doing this, by writing down this piece of code, what can I now do in my code? How can I now call my what could I now do? Class 1 O is equal to new class 1. And how do I now access this? If I have to call the set, what would I do? O of some index, let's say 0, equal to some value. This is the code that I was writing here sometime back. Okay, O of 0 is equal to 10. Similarly, O of 1 is equal to 20, and so on and so forth. Are we getting this? So look at this. What has happened now here? You have created, class 1 O. And what is the indexer allowing you to do? What is the indexer allowing you to do? What is it allowing you to do? Treat an object of the class like an array or a collection. Okay, that is essentially the job of the indexer. So the square brackets that you see here are your indexer. Anywhere else that you had seen the word this? Anywhere else that you've seen the word this? I'm talking about with reference to the square brackets. Do you see a method or a property called this? I don't know if you remember, but an array list, when you create an array list and you said O dot, it does show you the word this. So that is your indexer at play out here. Okay, now we have done this. We have done this. So what should we do out here? Where should we store this value? Where should we store this value? The value that I'm passing here, where can I store this value? Internally in the class, where will I store it? In case of a property, you needed to create one variable. But in the indexer, how many values can be passed out here? How many values can be passed out here?
No limit.
More than one, multiple values can be passed here. So internally, to store these values that are being received here, you would use either an array or a collection. And the array or collection would allow you to store the values that you are receiving through the indexer. All right. Let me keep it simple, simple and keep an array out here. Internally, to store these values, I would take a private int square brackets ARR. What is this being used for? For storing the values out here. Okay. Now, when you look at this line of code, O of I is equal to 10. O of I equal to 10. O is going down as this. 0 is going down as I. And 10 is going down as value. Just like you had for the property. The word keyword value. So this is what is going on here. And whatever values that I'm receiving here, I would like to store it into this array. I would like to store it into an array out here internally. So right now, let me just hard code this is equal to new int of, let's say 3, size 3. So help me with this code now. Help me with the code that I'm trying to write here. Whatever values that I'm receiving here has to be stored into this array. Help me with this.
ARR of I is equal to value.
ARR of I. Very good. Carry on.
Is equal to value.
Excellent. Superb. That's what you're doing for an index. Well done. So let's try and understand again what has happened. O has gone down as this. 0 has gone down as I. So the index that you're using here has come in here as I. And the 10 that you're receiving has come down as a value. So whatever I'm receiving here, I'm storing into ARR of, if this was 0, I'm storing into ARR of 0. If I've called this, in this case, I has the value of 1. So ARR of 1 will contain the value 20. Or ARR of 2 would contain the value of 30. This is what we are doing in the set. And what would you do in the get? On a similar line, can you help me with what I would do in the get?
Return ARR of I.
Superb. Same way. So all that you're doing here is, instead of returning a single variable, you're returning one element from that array. Whatever you had passed out here, this is what you return. And this is your index. All right. So if I try printing this now, console.writeLine, O of I, all right, O of 1 or whatever, or let's do this in a loop if you want to. I don't know how many properties are there, how many, how many elements are there. So what could you do out here? What could you do out here? If I wanted to know how many, what are the, I want to write a loop which looks like this. For each, or let's say for, not a for each. So for int I equal to 0, I less than length. What will you do in that case? Length here now I don't know. So what can you do out here? I want to do something like O dot length. I don't have O dot length, but I would like to type out O dot length. Okay. So what would I do for this to work? What can I do out here? Yes. This could be a property called length, which is a read-only property, right? And which returns what? How do I know how many elements are there?
So ARR dot length.
Right. So you could actually have wrapper functions, wrapper properties for whatever you would like to have. And I could now read it in this way, O dot length. Console.writeLine, O of I. Okay, so this is what I'm doing out here. The for each loop, for it to work, what will you need to implement? I don't have the for each loop right now. So if you want the for each loop to work, what will you need to implement?
Enumerable.
Enumerable interface. Right? And that would also help you work. So I'm not doing that for you, but that also could have been workable here. Are we clear on this?
Yes, sir.
Okay. Let's try running this. So all that it's doing is the values that I'm storing in here, it's printing out those values again. Okay. Now, I have gone ahead and actually me close the projects there. As I said, there are too many projects of mine open, so it's pretty confusing as to what each one is doing. Okay, so this is what I was looking out for. Look at the couple of things that I've, one extra difference that I've done here. What have I done out here? What have I done out here?
Size.
So instead of hard coding a value to 3, instead of saying that my array is of size 3, I'm doing what? Accepting the size from the user. Correct? This is what I've done. Okay. Check this out. I'm specifying that this is the array. This should be the size of the array. And the array elements should start from this location. So the starting point of this array element should not be 0, but should be whatever I'm giving in the start. Okay, all arrays normally start from 0. But for my class, no, not the array should not start from 0, but the object of my class, which is going to be treated like an array, should start from some other location. So I'm accepting this as here, and this allows me to do something like this. What am I specifying here? That my array should be of size, let's say 15. Okay, let's reduce it to, let's say 5. And how many elements? I mean, what is the start element out here is 2011. So now my first element here, when I say 2011, right? When I say 2011, what gets passed here is 2011. What am I actually doing? I'm returning what? Whatever the index minus the start. What was my start stored as? Start was stored as 2011. 2011. So if I'm saying O of 2011, this is actually saying index is 2011 minus 2011. So which gives me 2011 minus 2011 gives me 0. So I'm actually returning ARR of 0. So I'm actually giving it an offset. And using, smart little coding techniques like these, you can make an object of your class more flexible than your regular array that you are working with. Hold on, the battery is low. So this is what I've done out here. Are you all clear on this, everybody? So in addition to saying that my object should be treated like an array, you can add on more functionality to it. So that's precisely what an indexer allows you to do. I'm not going to run all this code. You can try this code on your own. It's just manipulating the array and making it work slightly differently. So you could try this one out. 1A, for example. Okay. Or let's make this as 1A. Make this as 1A. And this is 1. What would change out here? I don't have a length property, so this doesn't work. Let me add a length property. The code won't work, so let me not add a length property. So I'll not use this. What does this take as a parameter? First thing is number of, what is the size of the array? And secondly is what is the start point? So let's say start point, I give it as 100. How could I now access my code? O of this was my first code. Okay, so I'm keeping it this as is, and this one work. So this starts with what? 100, 101, and 102. And then I can actually do a console.writeLine O of 100. Okay, this is what I could actually do. These are the things that I have done in my 2 classes. One is the first one that I tried with you. Class 1 is the second one, which uses the concept of a different start point other than 0. So try out more examples with these and work with. All right. Any questions, any doubts with indexes? Okay, let's move away from indexes. I'm going to stop sharing for a moment while I I organize my stuff better. There's so many things open there. I'm able to. Okay. Moving on, let's go in for another concept out here. We're moving away from indexes, and we're going to try out reflection in .NET. So we have been saying all along that an assembly contains a couple of things along with that. There is firstly the code of your classes is in there, but in addition to the code, the assembly contains all your metadata. The details about the assembly are stored in there, including details about properties of the assembly, type metadata, details about the classes that you have in there, and so on and so forth. Now, when you use a utility like ILDASM, what is ILDASM actually doing? It is reading the metadata of that assembly, right? And it is showing you that metadata. So any metadata that is there, the ILDASM utility has read that and shown it to you. Now, this process of reading the metadata of the assembly or reading the contents of the assembly is referred to as reflection. So reflection is essentially opening an assembly and reading its metadata. Okay. Now, what can you do with this metadata? What can you do with reading the contents of an assembly and reading the metadata of that assembly? This can be used in different scenarios. First, simple scenario, just maybe a utility like ILDASM, just displaying what the assembly contains, right? Second possibility, and more sort of advanced possibility, is reading the assembly at runtime and creating an object of one of its classes in the assembly. Now, normally, when you work with reflection, or normally when you work not with reflection, let's say normally when you work with any assembly, to use that assembly, you need to first add a reference of that assembly. Unless you add a reference, you can't use the assembly. Now, what reflection allows you to do is at runtime, you can pick up an assembly without adding a reference. You can look at the contents of the assembly and you can create objects of that assembly, or you can call the methods on those objects. So essentially, dynamically load an assembly and call code on it. Now, this can be useful in situations wherein you don't have the initial assembly when you're writing your code, but at runtime, you ask the user which assembly he wants to load, and based on the user choice, maybe you read an assembly and call methods from there. So this leads to a little more dynamic coding. That's the second and a little advanced option that we would be trying out. Okay. The third thing that we will not be trying out, but I just want to mention that, and you should be aware of it, is you can actually create an assembly at runtime. You can create an assembly at runtime using something called as reflection.emit. So reflection.emit allows you to give out IL code. So IL consists of what are known as opcodes. And if you know IL, if you know how to give out IL, you can actually use reflection.emit to create assemblies at runtime. So which is a very, very advanced option for which you need to have thorough knowledge of IL to begin with. And then you can, use reflection.emit. But if you want, you can just make a note of it and, read up on that or try out. Maybe there'll be articles on reflection.emit that you can see how they're doing it. All right. This is a knowledge point of view. You need not be trying it out because, as I said, that's extremely, complex and, advanced code. But we'll try out the first two options that we mentioned. First one was reading the contents of an assembly and showing you the contents of the assembly. That's the first thing that we'll try. That's the simplest thing that you can do with reflection. Secondly, create an object at runtime using reflection. These are the two things that we're going to try out here. Okay. Let me add another project. Do not call the project reflection because there's an inbuilt namespace called reflection. It might clash with that. Okay. Okay, now all the classes that you need with this are available in system.reflection namespace. So we would be referring to certain classes that I've added a using on that. Okay. If you had to read the contents from an assembly, the topmost object that right at the start, you start off with an assembly. Okay. So there's a class called assembly. All right. System.reflection.assembly, which gives you details about an assembly. Now, this has some static methods in here. Let's see some of these static methods. All right. Assembly.getAssembly. And see what it takes as a parameter. Assembly.type. So any data type that you have, any type that you have, you can pass it out here and it will give you information about the assembly in which, or rather the assembly which contains this type. So supposing I have an employee class, which is in another assembly, I will pass that to it and it can give me information about the assembly which contains employee. Right, that's assembly.getAssembly. Assembly.getExecutingAssembly. Any guesses what that would be? Get executing assembly. One, what is executing assembly?
So the current assembly which is right now working.
Correct. the current assembly which is currently executing. So this is giving you details. So this is giving you a reference to that assembly. Right? Wherever your code is running, give me details about that current assembly. Get calling assembly. What is get calling assembly? Supposing assembly 1 calls assembly 2. So for assembly 2, assembly 1 will be the calling assembly. Supposing you are calling code in some other assembly, the other assembly will be the called assembly, and for that called assembly, your assembly will be the calling assembly. So when you call, when your assembly is being called from someone else, that would give you the calling assembly. Right? Now supposing assembly 1 calls assembly 2, assembly 2 calls assembly 3, and assembly 3 calls assembly 4. Let's say there is a hierarchy of assemblies. And if you are in assembly 4, so 1, 2, 3, 4 was the order in which they were called. Assembly 4, what is the calling assembly?
3.
3. For 3, what is the calling assembly?
2.
And for 2, what is the calling assembly?
1.
1. But if I'm in 4, and I want to find out which was the first assembly that was called, that is my entry assembly. So entry assembly is the first one in the hierarchy that was called.
So can we also say that entry assembly is the one where main method is written?
Correct. Yes. Okay, because your start point is going to be from main. So main will call some other assembly will call some other assembly, and so on and so forth. So yes. So that's your entry assembly. Are we clear on this, everybody? So these are different methods that give you details about the assembly. Now you also have these load methods, and there are different variations of the load methods, right? And one of the options out here, okay, now I don't remember whether this is the correct option, assembly.load is the file name that you have out here. Or it's from load file, load from maybe it is. Load file, is it? I think load file. Yeah, load file. I mean, I do not with load, but load file gives you what? The file name you pass to it, and it will give you that particular assembly. So I'm going to use this one, load file. Okay, and I'll pass the file name out here. And this returns an assembly. All right, so this is my starting point. I'll give the file name in a minute. Once you have an assembly, now everything in that assembly can be found out. Now, if you do assembly dot, all right, all the details about this assembly, all the properties about this assembly are available out here. All these properties are available here. Okay. One of the properties there is full name. So let's try printing this full name. All right. Let me pick up an assembly that I have. So I have it in my D drive. Okay. whatever. Maybe that might be two these. Day 2, let's say. Properties bin debug and properties.exe. So this is the assembly that I'm loading out here. Okay, I'm hard coding the value right now. Now, when I hard code this value, okay, it's showing me an error because it's taking the slash as an escape character. So, for example, /t, right, has a different meaning when you're writing, C++ code or C code for that matter. So slash, all of these slashes are having different meanings. Okay. Now, how do you specify that? Ignore the special characters. How do you do that? One possibility is you go and give a double slash everywhere. So everywhere, instead of a slash, you do what? Double slash. But that's pretty painful, isn't it? Like in this case, I have to give like about 6, 7, 8. I don't know how many are there. Right? Those many double slashes I have to give. The other option, which is the preferred option, is before the quotes given an @ sign. And this indicates that everything that you're giving with the slash, it's not a special character, it's not an escape character, but instead should be treated like a slash itself. So that's your @ out. Okay. Before the quotes, not in the quotes. So let's try running this. Okay, and this was the full name of the assembly. The full name of the assembly consisted of the name of the assembly, the version number, the culture, and whether it has a public key or not. The public key is a concept that we'll probably be covering tomorrow only. Okay, so we'll have a look at what these are. But that's how your assembly full name has been picked up. All right. Instead of this, if I wanted only the name of the assembly, so you have a property here called assembly.getName. It's a method, in fact. And getName returns an object of type assembly name. And then this assembly name dot, again, this has details about the assembly. And this can be individually now picked up. Like, for example, assembly name dot name would give me only the name of that assembly, which was properties in that case. Okay. Now, what I want to do here is this. I want to get the assembly name out here. Now, under the assembly name, I want to show all the classes in the assembly. I want to show all the classes like this. Class 1, class 2, whatever classes that I have. Class 3, and so on and so forth. Okay. So that's what I'd like to do. And under the classes, I would like to show all the method names out here. So supposing this had different method names, method 1, method 2, and so on and so forth. Right? Whatever method names that I had. Okay, this is what I want to show out here. And under the method names, I want to show the parameters out here. So param1, param2, and so on and so forth. And this, of course, would keep getting repeated. So this is what I'd like to show. This is the values that I'd like to show. So obviously not ILDSM, but something like ILDSM. In ILDSM also, what are we doing? We are seeing all the classes, methods, properties, whatever, all of this. So this is what I'd like to do. Now I have given you the first part, which is what? I've given you the assembly name. What do I want after that? What are
All
these?
classes name.
All classes. Another word for class. In .NET, another word for class.
Reference.
Another word, types. Generally, you refer to them as types. So what I want here is all the types that are there in that current assembly, right? And to do that, you have a method here called assembly.get, and then you have different details about the assembly. So for example, you have something called get type and get types. So you have two methods, get type and get types. When you say get type, this will return you details about one particular type. Whereas get types, right? Get types is all the types that are there in the assembly. Let's see what get types returns. What is this returning here in this case? Returning an
Type
array of type objects. So type, square brackets, let's say ARR types is equal to assembly.getTypes. Right. Help me display all the types out here. Give me the code for displaying all the types here under the assembly. Can you help me with the code, please? I've given you the array. Now I want all the types out here. So help me. Yes. What is this returning? All the classes in this thing, or all the types in that assembly. So what would I do now? Yes. Come on.
Each type T1 in array types.
So write a for each loop, right? Or a for loop. Collection here, of course, was ARR types, and one item in there was yes, type T in ARR types. How do I get the name of the class? How do I get the name of the class? Come on. Intuitively, what do you think would be the property?
T dot name.
Right. So coding doesn't have to be only knowing it beforehand. This is very intuitive coding. I mean, it's fairly easy to understand. Okay, now I've got my classes out here. I've displayed all the classes here. Let's try running this code. Right. So properties of the name of my assembly, and then you had what? Program, class 1, class 2 were your classes. Right. So this is what I'm doing. And you see all the classes. I'm just putting in a little indentation out. Okay. Next, what do I want? For each class, what do I want? For each class, what do I want?
Method.
So any guesses on how to get that? Any guesses on how to get all the methods for that particular class?
T dot methods.
Get
Correct.
methods.
Only thing is T dot
Get methods.
get methods. Right. So actually, every day after the session, Kaustubh calls me up. I've given him my private number. Every day he calls me up, and then I take with him what we want to cover the next day in the session. That's why he asks so many questions and answers so many questions and is so interactive. So, Kaustubh has my number, and every day he calls me, and I tell him, this is the question I'm going to ask in the class, and this is the answer that you have to give. All right. So let's have a look at this. So T dot get something. Now, if you look at T dot get something, there are so many different things that you can get. Like, for example, T dot get constructor will give you details about one constructor in that class. And get constructors gives you details about all the constructors in that class. Get constructor returns what? Look at this. Get constructor returns what? What are the object that it returns? Constructor info. And get constructors returns an arrays of constructor info. Okay, I've not covered attributes with you. But if you look at this, get event will give you what? Details about one event in the class, which you're getting it as event info. And get events is all the events out there as event info array. Get field will give you details about one field in the class. It will return field info. And get fields is all the fields in that class. All right. So like this, there are so many different get methods giving you practically everything that you want to know about that class. And that's how ILDSM is working. It's actually reading all this info and showing it to you there. Right. Now, one of the methods out there was get methods. Get method and get methods. What does this get methods return? Here in this case, look at this. What is this returning? Yes.
It's an array of method info.
Method info. So let's try calling get methods. And on my left hand side, what do I get? Method info. Square brackets. Let's say ARR methods is equal to T dot get methods. So now this is giving me all the methods in that particular class. T dot get method. T was your type. Type is a class. So you got all the methods. How do I display all the method names? How do I display all the method names?
So with for each loop.
Go through the ARR methods, run a for each loop. And each method, how do you know, get the name of the method? Any guesses what that would be?
Method name.
Just name. Just name. All right. Something, m dot name would give you all the names of the methods. All right. I'm not writing that down. I'm not writing that one down. You're going to do that one. Loop through ARR methods. Achha, now, how do I get all the parameters for that method? How do I get all the parameters for that method? Yes. Any guesses? Come on. This is so simple. I don't know why you are not answering.
Dot get parameters.
What dot get parameters?
Get fields.
What dot get parameters? You're saying dot get parameters.
Method info dot.
Yeah, method info object dot get parameters would give you all the parameters. How do I know what is the name of the parameter? Parameter
Get
dot
names.
name. Dot name. Right. So the sky is the limit. I have only asked you to do what? I only asked you to do assembly name, class name, method name, and parameter name. That's the only 4 things that I'm asking you. But the sky is the limit. You can display whatever you want from that assembly. When you ask me a question, sir, can this be done? Before you ask me the question, I'm telling you the answer is yes. You can get information about that from reflection. But I'm asking you to, given the time constraints, I'm asking you to create a small subset of that. Otherwise, you all can, if I give you 3-4 days, you all can create ILDSM using reflection. Right? We don't have 3-4 days. So just do this. This is a to-do. Take a screenshot of this or photo of this. I'm not sharing it as an assignment, but essentially you have to display these values from here, from any assembly, to pick up any assembly. Are we clear on this? This is what is expected of you. Questions, if any? Yes.
When we use get method, the singular one, which method will it return?
It will take a parameter about which method you want. So let's look at all of these. Let's start with, you had a get types. So here you would also have a get type. Look at what get type takes as a parameter. See what it takes as a parameter. Yeah. Does that answer your question?
Yes, sir.
All right. So similarly, if you had to get a method, so you're doing it as t.get method. So again, there will be overloads to this, but look at what the simplest one is get method of the name that you give out here. Now there are complications to this also. Like for example, you could actually have two methods having the same name. Possible? Can two methods have the same name?
Yes. Overloading.
Yeah, overloading. But when you have the same name, their parameters will be different. So there are further overloads there where you specify the parameters out there for that method. If you have a simple situation where there is only one method, then that simplest option that you had would be good enough. So I would like you all to complete this example, the one that I've asked you to do, complete this example. And I'm going to continue with reflection in the next session again, wherein I will presume you know all these methods. All right. And on that presumption, I'm going to teach you a few other things. But very important for you to understand the code, it's going to be cryptic code. But to understand that code, you need to have tried out this code first. So when I say something, you know that, okay, this is what he's talking about. Somebody's mic is on. All right. So take a screenshot of this. I'm not giving it as an assignment in words, but this is what I would like you to do. Okay, using reflection. Are we clear on this? Questions, if any? Okay, I'm not taking the second example in reflection purely because I want you to try this before I do the second one. The second example of reflection that I'm going to show you is how using reflection you can create an object of a class at runtime, call properties, methods, whatever, specify constructors, whatever the case might be, how you can do that at runtime without adding a reference to that object. And that is a little more complex than what we have done out here. But for now, this should be good enough. Okay. Let me take another topic, again, related to an assembly itself. We're going to be seeing the concept of what is a private assembly and a shared assembly. And we're going to see how to create shared assemblies. You have already created private assemblies. Okay. So let's try and understand firstly what is happening here before we get into the actual creation of a shared assembly. Whenever you are using another assembly, okay, so let's say this is project 1, right? This project 1 has, let's say, a main method. So this is actually going to give you a .exe. Okay. Now, if project 1 wants to use project 2, And project 2 here is, okay, I'm just giving an example. So this is, let's say, a console app, okay, which has a main. And project 2, for example, is, let's say, a class library. Remember class library, everybody? What is the class library? What are the difference between a class library and a console app? What are the basic difference between the two?
So no
Main
entry point.
method.
No entry
No
point.
entry point, correct. Well done. And what else? On compilation, what do you get?
So DLL file in class library and exe in console app.
Correct. Correct. Right. So these are things that we have done before. Now, assuming project 1 has to use project 2. To use project 2, project 1 has to add a reference to project 2, correct? Now, when it adds a reference to project 2 in its bin folder, right? Inside the bin folder, there will be a debug folder created. And inside this debug folder, you would firstly have your own assembly, project1.exe. Okay, you will have this assembly out here. But when you add a reference, it also gets a copy of project2.dll. Every time you add a reference, when does this happen? When you add a reference, you get that other project 2 into your first project. You get that file, you get a copy of that file. Now, such a situation where every time you add a reference, when you get a copy of your file, such assemblies like this assembly here, project 2, for example, is an example of a private assembly. Is an example of a private assembly. So what happens in the private assembly? Every time you add a reference, what are you getting from a private assembly? What are you getting? You're getting a copy of that assembly to yourself. Are we clear on this, everybody? All assemblies that you have created so far in .NET, every assembly that you have created so far has been a private assembly. An assembly that if somebody adds a reference to, would get a copy of that assembly. Are we clear on this, everybody? So now you have to understand why have they done this? What is this? What is the reasoning behind doing something like this? To explain to you the reasoning behind this, I have to take you back to day 1. And we said that one of the reasons why .NET came was because COM had problems. And one of the problems that COM had was that when you were, having versioning, and versioning involved in, if you had 2 copies of the same code on the same machine, when that was a COM object, it would create problems in your code. So what are the problems it would create? What are the issues that it would create? If version 2 was installed on the same machine that had version 1, version 2 overwrote version 1. Version 2 overwrote version 1. And which meant that if you were trying to call some code in version 1, and the new code that has overwritten that code is not compatible with that original code, then your COM object would not. So this was the issue that was there in COM. And there was a workaround to this issue, but it was not implemented as a rule. It was implemented as this is what you should do. It was not implemented as this is what you have to do. All right. What should you be doing? You should be trying out all the code between this session and the next session. This has been told to you. You should try it out. but it has not been enforced. It is not, you have to try it out, otherwise you're not allowed for the next session. Right? So some of you all try the code and come, some of you all don't try the code and come. Okay. Similarly, in COM, there was certain specifications saying that, okay, if you want to bring in a newer version, these are things that you should do, but not everybody did them. And that's where the problem came up, wherein the newer version overrode the previous version. And that happened because the new version and the old version were both being stored in the same location in the Windows registry. The Windows registry was actually holding on to these values, and it was overwriting the values. Version 2 was overwriting the values that version 1 had. So this was the problem that was there earlier in before .NET. In COM, this is the problem. So when .NET came about, they said we will eliminate this particular problem of COM by having private assemblies. And what happens with the private assembly? You get a copy of that assembly. So now you have your own assembly with you. Now supposing I'm just giving you another scenario. Let's say there was also a project 3. It was also a project 3. And in this project 3, right, in this project 3, this one also added a reference to project 2. This one also added a reference to project 2. What would happen now with this project 3? Project 3 would also get what? Would also get what? A separate copy of project 2.dll. So every time you added a reference, your assembly is getting a copy of that. Now this copy is different from this copy. This copy is different from this copy. So each assembly has its own private copy. Now assuming project 2 changes and project 2 comes up with now, so this was, it had a project 2.dll version 1. Okay, so you got version 1 out here, you got version 1 out here. So this is what it had. Supposing this came up with version 2. It came up with version 2. What would these assemblies continue to have right now? Project 1 and 3, what will it continue to have? Continue to have what? Which version will it have? Which one did it have when it was added as a reference? It has version 1. Now, what if version 2 is not compatible with version 1? What if version 2 is not compatible? Not compatible meaning what? Let's say in version 1, there was a method that took 2 parameters. In version 2, you have made it a method that now takes 3 parameters. What if it is not compatible? Then what would happen now in this case? Will this other code continue to work? Will it continue to work?
Yes, sir.
Why would it continue to work?
So they are independent because versioning is different.
Because they have got a different copy. They've got their own private copy. So even if something changes somewhere, they are not affected by that code. And that is the concept of using a private assembly. A private assembly ensures a copy to yourself, which will not be overwritten by someone else and which will not cause problems in your code. So they said the versioning problem of COM, we will solve it by making all our assemblies in .NET private by default. So all assemblies that you have created so far, all of them have been private assemblies. You don't need to do anything extra to make it private. They are already private by default. Are we clear on this, everyone? Yes? Clear on this? Any questions regarding this? All right. Now, let's take another scenario. Let's take another scenario. Now, the other scenario that I'm giving you is, let's say, this was P1, this was P2, this was P3, this was P4 up to Pn, let's say. Right? And each of these, P1, P2, P3, P4, each of these picked up something which is an external assembly. So let's say this is, assembly1.dll. Okay. And let's say this was version 1. So each of these was using assembly1.dll. So when you add a reference to this, what are they getting? Each one of them is getting what? Each of them is getting what?
A
What are they
copy.
getting? Their own copy. Okay, so this is how it's working by default. Now let's assume assembly2, assembly1 changes and it comes up with a different code out here. Okay, it comes up with a different code out here. Right? And let's say that the code is backward compatible. Meaning what? That you have made it in such a way that your existing code will not break. That existing code will also work and you have added newer features. Okay. Now in such a case, I want to put this version 2 out here. I want all of them to use version 2. Will it work by default? Will it? By default, which one will they have? All of them will have what? Which assembly will they have? Version 1 they'll have. So to make version 2 work here, what will you need to do? To make version 2 work here, what will you need to do?
Copy of version 2.
So you will have to go and copy this version 2 everywhere. Right? You'll have to copy it everywhere. Now, what if it was being used in 5,000 different projects? What if it was being used in 5,000 different projects? What will happen then? Copy it where? In 5,000 different projects. Yes or no? 5,000 projects on that one machine only. Okay, I'm giving a outlandish number just to drive home the point. So now instead of doing it this way, what if I can go and make changes at one place? I can make changes at one place, and by making changes at one place, all these projects would automatically now refer to the new assembly. What if I could do that? What will be the advantage in this method?
Yes.
So reduced effort.
Easier to maintain.
Yes, sir.
What is the problem? What is the problem? What is the issue in this method? What is the pro is easier to maintain? What is the con?
The code has to support back like the previous code.
Correct. And if it doesn't support, suddenly it will crash. It will stop working. Right? That problem with my power adapter, it suddenly started smelling. So it's probably a short circuit in there. All right. Now, what .NET says is that you all had the problem. You, the developers, had a problem with the previous COM application. See, COM actually worked this way only. It said that if you make a change at one place, this change would be reflected everywhere. But the problem was what? That the change that you're making, if it was not backward compatible, then you are in trouble. And this is the default way in which COM worked. So COM didn't have an option of, let's say, something like a private assembly, something similar to a private assembly. It didn't have. It just had this option. And for people who did not make their code backward compatible, it caused problems. So when they say versioning was a problem, versioning was not a problem because of COM. Versioning was a problem because developers did not follow the guidelines that they were supposed to follow. All right. Now .NET says what? See, I have solved your problem. I've given you what? I've given you a private assembly. Now, if you want to put in another assembly, which is a shared assembly, which says that if you make a change at one place, it will be reflected everywhere. If it doesn't work, don't come back and tell me. Because what am I doing to begin with? What am I giving you to begin with? I'm giving you a private assembly. It's working fine. And now if you decide to make it a shared assembly, you'll have to firstly go through a set of steps. And if it still doesn't work, it's not my problem, it is your problem. So this is what is now the suggested thing. Suggested thing is what? Make all assemblies as private by default. Versioning problem sorted. But if you're going to ensure that it is backward compatible, you can consider making it shared. Now, how do you make it shared? How do you make an assembly shared? To make an assembly shared, you have to install it in a common area called as the global assembly cache. Right? What is this global assembly cache? This is a common area where your shared assemblies are installed. Okay. Now to install it in the global assembly cache, I'm going backwards. That is the end result. That's the end goal. But to install it in the global assembly cache, your assembly must have a strong name. All right. Assembly must have a strong name. And to have a strong name, you need to sign it with a key pair. I'll explain all of these. Give me a minute. But let me go backwards. So we want to put into the cache, into the GAC rather. For which prerequisite, it must have a strong name. To have a strong name, it must be signed with a key pair. And then, of course, you need to generate the key pair. Right? So you need to generate a key pair. Then sign the assembly with the key pair. Then it has a strong name. And then it can be installed into the GAC. So this is a sequence of steps that we're going to follow to make a shared assembly. Are we clear on this, everything? Now, first question is, what is a strong name? So strong name is, a unique name that the assembly will have, which will not be duplicated by any other assembly. Essentially, a strong name is something by which we can identify an assembly. That's a strong name. Now, how do you give it a strong name? To give it a strong name, the assembly must have a key pair, must be signed with a key pair. So this key pair is actually a public and a private key pair. So this signing with a key pair is a concept used in cryptography. Right? And you need to do that. So which means you need to generate a key pair. So the key pair, actually, there's something called as a public key and a private key. Public key can be seen by everybody. Private key is only known to the application itself. So you have to generate a key pair, sign the assembly with the key pair, right? Then it has a strong name, and then it can be put into the GAC. So we're going to do all of this. Questions, if any? All right, I'm not doing it in this solution. I'm going in for a new solution. Okay, the assembly that I'm going to create as a shared assembly, I'm keeping this as a library, as a class library. Okay, so that's the one. Class library for .NET Framework. Okay, I'm not changing the name. I'm calling it as class library 1 itself. I'm not creating a solution for that specifically. It's just going to be there in that folder itself. Okay, create. Okay, so it's a simple hello world type this thing. Okay, so that's your class library that I've created. What do we need to do with this? Sorry. What do we need to do with this? Firstly, we need to generate a key pair. Now you can do it in two ways. You can either do it at the command line or you can do it from Visual Studio itself. Right? I actually can do it from Visual Studio, but in the exam, they will ask you the command line also. So I'll show you both. So go to this, what do you say? Visual Studio, the developer command prompt, and run it as a administrator. You need admin rights to do the next steps. So run this as an administrator. Right? Go to the folder that you have created your projects in. So in my case, it's in the D drive. CD training / JK July 22. Okay. CD training. Trainings. Okay. CD training / July 22. Right. Go to the folder that we have created. We had called this as class library 1. So class library 1. Right. And let me generate this strong name key pair. To generate this, you have a command called SN. SN is short form for strong name. -key, -k, sorry, and then the name of the key. So whatever the name of that key file. So let's say key1.snk. So this is going to generate a file called key1.snk, which has your key pair file out there. That's step 1. Okay, so key pair has been written to this file. So what are the command that we gave here? SN -k and whatever key1.snk. So this is generating a key pair. Then you sign it with a key pair. So to sign it with a key pair, you need to go into the project properties. This is in Visual Studio. Visual Studio, project properties. Right? Go into the signing, and that's where you specify this. Okay. So properties, go to the signing, and you say sign the assembly. Sign the assembly, and choose a strong name key file. So either you can go in for new. What will new do for you? New will generate a new file. So it won't use the file that I have created. So this is what I said. I don't need to do that at the command line, but you need to know the command line, this thing purely from the point of view that it might be asked in the exam. The second option is you could go into browse and go to browse and pick up the file that we had. So, in class library 1, we had created a file called key1.snk. So that's the one that I'm using. If I had chosen new, then don't protect it with the password, but file name could be, let's say, key2.snk, and enter this. So it creates a key2. So what is this using now? This is using key2. If you want key1, you can use key1. Whichever key that you're using, you can use this. So this is what we have done. So we have signed the assembly with the so Visual Studio. Now to have a strong name, just build the assembly. Once you've done the signing, what is the next step that you have to do out here? All that you do is you build the assembly. Remember, you can't run the DLL file directly. You can't press F5 to run it. So what you would be just doing is building the solution. And at this point, there's no compilation errors and all of that. At this point, the assembly has a strong name. Are we clear on this, everybody? Clear? Assembly has a strong name. Next step, install it into the GAC. Install it into the GAC. To install into the GAC, we have to go to the command line and give the following command: gacutil /I for install, and the name of the DLL. Okay, so this is what we're going to do out here. Where is this DLL going to be created? In which folder? We are in class library 1. In which folder will this be created? Yes.
Same folder?
No. Bin debug.
Actually, yeah, right.
So cd bin and cd debug. This is where it's getting created. So if you look at the directory out here, it has created your class library 1.dll. Okay. And here is where you give the command out. So command that we gave here was what? Same thing that I copied out there, which was gacutil /I and class library 1.dll. It should give you a message here which says assembly has been successfully added to the cache. And if that is the case, then you're good to go. Your assembly is now installed into the GAC. Are we clear on this, everybody? All right. So this assembly is done. It's installed. It's working. let's create another project which uses this assembly. So this project that I'm creating would be a console app. Okay, that's a console app. And I'm just calling it as client for shared assembly. Please don't write down the word assembly in short. Write it down in full. I see, sir, my shared short form for assembly is not correct. Okay. Anyway, create. Okay. Now, how do we use that assembly? What do we do to use that assembly? You just add a reference to it, like you would normally add a reference. So let's add a reference to this. Right click on references and add a reference. Right. While adding the reference, now it won't show up here in the solution. Why will it not show up in the solution? Yeah. You don't have it open in the solution. So go into browse. Okay. Go into browse and go to the folder where you have saved this. So trainings, whatever, JK July 22, class library 1, bin, debug, class library 1.dll. Right. So that's the one that I want to pick up and then just say OK. All right. Now you will find that by default, it actually includes this into your current project out here. It adds it to the current project by default. In the sense, it adds it to your folder, even though it is a shared assembly. Now, why does it do that? Why does it, even though we have kept it as a shared assembly, why does it still add it to the folder? The reason being that tomorrow, after you finish your development, you have to take this project of yours or this folder of yours and you have to install it on the client location. This is not your client location. This is your development machine. So what it says is whatever files you need, I will put them into your current folder in any case. It does that by default. But I don't need that file to run. So I'm going to go into the properties for this. For which one? Properties for this class library 1. I'm going to go into that. And there's an option here which says copy local, which I'll make it as false. So copy local says what? Whether you want a copy of that in your current folder or not. A shared assembly, you don't need a copy. A private assembly, you always will need a copy. If you give false for copy local for private assemblies, it will give you an error. But for shared assembly, this would work fine. So I've said copy local, set it to false. And let's try calling the code from them. So all that we're doing here is what? Class library 1 dot class 1 O is equal to new class library 1 dot class 1 and console dot write line O dot hello. So this is what we have done. For good measure, put in the console dot read line. So this is of course the client application which is reading that. And let's try running this. This works fine, no problem. I mean, this is standard code and you got your hello world or hello or whatever is being returned out there is being shown here. Okay, so you got your hello from the other one. But I'm more interested in showing you what are the files that have got created. So if you go back to this folder and if you look at client for shared assembly, in the bin, in the debug folder, you will find that class library 1.dll is not added out here. It's not added out here. So that was your shared assembly. Where are you referring to it from? Where is it being referred to from? From the global assembly cache or the GAC. So it's actually picking it up from there. Are you clear on this, everybody? So I don't have a copy of that out here. Questions, if any? Question. Let me add another assembly. I'll add one more assembly, which is a private assembly. So somewhere else we have created a DLL. Where else? Let me add one more reference. Browse. And somewhere else we had created a DLL. I think in the inheritance examples. This test access specifiers was a DLL. Bin debug and test access specifiers.dll. So I'll add that also. Okay. And then test access specifiers. Remember this one? We had written this one. Base class O2 is equal to new base class and console.writeLine O2 dot, and then you had only the public member available here. So let's try running this. So now I have two references. I have a reference to class library 1 and I have a reference to what? This test access specifiers as well. So I have two of them. But if you look at the folder out here, you'll find that the test access specifiers is required out here. You need that file out here. Whereas you don't need the file for the class library 1, which was your shared assembly. Are we clear on this, everybody? Questions, if any? Okay. At some point, okay, not here, but at some point, you might want to uninstall it from the GAC. So instead of install, what are we giving out here? Uninstall. Any guesses? Install was I, uninstall would be? Uninstall would be?
You.
And while giving that, you don't need to give in the DLL, just give in the name of that assembly. So again, this is a question that may be asked again in the exam. Wherein, how do you install something into the GAC or uninstall something from the GAC? Okay. Just put that out in the chat window so you can keep that as your notes as such. All right, so that's what I wanted to show you. Questions, if any? Okay, so we'll stop here for the day. I'm not copy pasting the code out there, right? For the shared assembly or the client, I'm not copy pasting. More important than copy pasting this code was the the steps involved in making an assembly a shared assembly. So if you have any things, look through those steps and see how we did that there. Okay. So I'm ending the session here and I will see you in the lab. Bye for now. Give me 5 minutes to copy them.
Thank you, sir.